Now we're going to do these compounds with using the polyatomic ions. This list of them, you definitely want to have this available to you. And as I said, these just work, mostly all of them, except for ammonium, acts like a nonmetal. So let's start with acetate. So there's acetate, C2H3O2, and it's charged -1. All right, so let's do that. Let's see. All right, so C2H3O2, and it's charged. And we generally put parentheses around these. In fact, when we come up with the proper chemical formula, we're gonna use that. I should have given a little bit more room. Suppose we have. Let's see. Let me find some. I'm just going to go off the periodic table here. So suppose we had calcium acetate, let's say. All right. So calcium acetate. Calcium is Ca plus. I'm going to do it right here. I should have given more room, but so +2, right? Because it's oh, they can't see that. +2. All right, they're too close together, but you get the idea, hopefully. So we're going to do the crossover technique again. So the 1 right here, this is a 1 with the acetate. That belongs as the subscript of the calcium. And then, now here's the thing. This is where if there's more than one acetate, and there clearly is here, there's 2 of them, we have to put the parentheses. So we put the parentheses, and we put the acetate, the polyatomic ion, C2H3O2, all right, and that sticks together. Okay, this is something that I should mention, is that you don't break these apart. That stays together as one thing, and then the 2, so using the crossover technique, belongs down here at the bottom of the parentheses. And it doesn't need to be reduced because it's already in the least common factor. So this Ca, and then in parentheses C2H3O2, but there's 2 of them, right? So there's 2 acetates for every 1 calcium. That's simply called calcium acetate. If you're like me and you forget how to spell stuff, you can always just go right here, and that, all of the spellings of all these things, you're not required to know that. So acetate. All right, so there it is. Let's put that on here. Calcium. So calcium acetate. So that's the proper name, and this is the proper chemical formula. So both of this calcium acetate, or Ca in parentheses C2H3O2, and close parentheses, there's 2 of them. So both of those are calcium, what we would consider calcium acetate. So the whole thing about this is you got to be able to go either from the chemical compound, or you go to the from the chemical compound to the proper name, or the proper name to the chemical compound. Notice we did not change this to IDE. So if you hear something, and in fact, let's go back to our table 9.3, which again you want to have that when you're doing these. You want to have. Oops, went a little past it. Notice only 2 of these things end in IDE. So remember, generally, if something ends in IDE, you go looking for it. It's a nonmetal on the periodic table. Oxide, sulfide, fluoride, right? Things like that. But there are two exceptions. Here are the two exceptions. Cyanide, which is Cn minus, and hydroxide, which is OH minus. So hydroxide and cyanide, you have to remember that those are not found on the periodic table. Okay, but they do end in IDE. All right, let's do another one. We can actually do ammonium. So ammonium acts like a metal, right? So it's NH4, it's +1, and we'll do ammonium nitrate. So there's the NH3. All right, so we're going to do both of those. All right, let's get a little bit of room here. So ammonium is NH4, and it's +1, and nitrate is NO3, and I believe it's charged -1. And so you can actually just do the crossover technique with this. All right, and so in this case, notice there's just going to be one of the compounds. One of the polyatomic ions. So in this particular case, the NH4, there's one of them, right, from that, and the NO3, the NO3, there's one of those, and so this is the time when you don't need parentheses, right? So here, let's go back to the polyatomic ions. So here we are, right? And so, whoops, there they are. So ammonium is NH4, and nitrate. So remember, there's another thing called nitrite, which is NO2, but we chose NO3, and it's charged -1. So there's one of each of those, right? So it's how would we name that in the proper naming scheme? I mean, this is the proper chemical formula. You don't need any parentheses at all. So this is ammonium. Nitrate. So notice it ends in ATE. If it's nitrate or nitrite, again, that's not IDE. That's not our. So you don't go looking for something. So if you, in other words, if you started with this, and it said, okay, what is ammonium nitrate? You would say, nitrate. It ends in ATE. I go looking on the polyatomic ion chart, and I find, NO3, and I would use that as my non-metal, and then the ammonium, of course, is acting like the metal here. All right, let's see. Let's do a couple more examples. All right, so this is going to be putting just about everything together that we've learned about ionic compounds. So we have cobalt-3, so that's pretty easy. It's the chemical symbol for cobalt is capital C, lowercase o, and it's 3, so it's going to be +3. And notice the next thing that we have, the thing that's acting like a non-metal, is phosphite, and it ends, it's ending in ITE, so that tells me I do not go looking for this on the periodic table, right? That's not. There's no such thing as phosphite. Of course, there's phosphide if it was just phosphorus, but that's not the case here. And so here, let's we have phosphite, right? So phosphite is PO3. Remember that always sticks together, and its charge is -3. All right, so PO3 -3. So that's what phosphite is. Oops, didn't mean to do that. All right, so PO3. And it's -3. Okay, so again, we just use for cobalt-3 phosphite, we're going to use the crossover technique. So we have CO, and there's a subscript 3, and then there's PO3, but we have to put parentheses around that because there are 3 of them from the cobalt, so there's 3. But of course, this is an ionic compound. The phosphite is acting as a nonmetal. The cobalt, of course, is a transition metal, but it's still an ionic compound. So this reduces to CO. So that's cobalt. 3 goes into itself once, so that's it, and then PO3. So 3 goes into this, 3 right here goes into itself once. So since there's just one phosphite, the PO3, then you don't need parentheses now. Okay? So, all right. So probably need to do some doing homework will help us naming these ionic compounds, and also including if there are polyatomic ions as part of that. So this is our list of polyatomic ions. We're going to be using this. Let's talk about covalent bonds and how they are named. So a covalent bond, basically this is different. In ionic, they're bonded because one object is positive, the other object is negative. But in covalent bonds, there's a sharing of electrons that are going on. So by sharing the electrons, the atoms form a bond and become a molecule. All right. So how do we name these? Well, let's actually look at this. So for example, hydrogen bonds with itself, and basically that outer electron, that one outer electron between the two is being shared. Anytime 2 things are being shared, they put a little dash in there to indicate a single electron is being shared. This is just showing you, like, for example, carbon can share 4 different ways. The family 5, of course, can share 3 different ways. Family 6 can share 2 different ways because there's 2 free electrons, or there's 2 lone electrons. And then, of course, family 7 is just a single sharing that takes place. Okay, so if there's that sharing, remember we replace it with a single dash. So there's one sharing with 1 carbon atom and 1 hydrogen atom, 1 carbon and another hydrogen. But carbon has 4, so there's 2 more electrons that can be shared. And so this is what they call a double bond, just to let you know what that looks like. So there's a single bond, there's a double bond, and there can even be, especially for carbon, triple bonds. So, the carbon has 4 electrons to share. There's 1 of them, there's 2, there's 3, and there's 4. So this is also known as a triple bond, very strong bond. And this, in fact, the compound is called acetylene. You've probably heard of acetylene torches, very, very hot. All right, let's see. This bond polarity is really, really trivial. What you do is you use this chart. If the absolute value of the electronegativity is 1.7 or greater, then what we're doing is we're going to predict that that's an ionic bond. If it's between 0.5 and 1.7, we predict it's what's called a polar covalent bond. And then if it's 0.5 or less, we could predict it's our traditional covalent bond. So polar covalent and covalent, what is the difference between those? Covalent is equal sharing. The electron can equally be found around this atom or this atom. Polar covalent, this atom is hogging the electron. The electron's spending more time near this atom than near that atom. Okay, so that's what we mean by that. We'll do some examples of this.